This video is about the calculus of trigonometric functions. At this point in the series, you know how to differentiate algebraic functions such as polynomials. However, you don't know how to differentiate non-algebraic functions such as trigonometric functions. This video will teach you how to differentiate trigonometric functions. First, we will start with sine of x. That can be differentiated using first principles. d sine of x is sine of x plus dx minus sine of x. Using the compound angle rule, we can expand this out to sine of x cos of dx plus cos of x sine of dx minus sine of x. We can simplify this by grouping together terms which contain sine of x. Now we take out a factor of dx. We replace the dx's inside our brackets with a h and take a limit as h tends to 0. So the question becomes, what is the limit of cos of h minus 1 on h and sine of h on h as h approaches 0? Well, if we graph them both on Desmos, we can clearly see that a limit of cos of h minus 1 on h as h approaches 0 is 0, and the limit of sine of h on h as h approaches 0 is 1. This means that our differential is sine of x times 0 plus cos of x times 1 all times dx. Therefore, in total, d sine of x equals cos of x dx. We can also do the same thing to cos of x. d cos of x is cos of x plus dx minus cos of x. Using the compound angle rules once again, we can expand this out to cos of x cos of dx minus sine of x sine of dx minus cos of x. Grouping together the cos of x terms, taking out a factor of dx and taking the limit, we end up with our answer of negative sine of x dx. It's interesting because d sine of x is positive cos of x dx, but d cos of x is negative sine of x dx. Now we can differentiate tan of x. Tan of x equals sine of x divided by cos of x. If we move the cos of x to the other side, we get tan of x cos of x equals sine of x. Differentiating both sides, we get d tan of x cos of x equals d sine of x. We can apply the product rule on the left side. Because we know what d sine of x and d cos of x is, we can substitute those in, and after a bit of simplification, we end up with d tan of x equals sec squared of x dx. It's a very similar procedure to differentiate cotan of x. You end up with negative cosec squared of x. Finally, we can try differentiating sec of x. Sec of x equals 1 divided by cos of x. Moving cos of x to the other side, we get cos of x sec of x equals 1. If we differentiate both sides, we get d sec of x cos of x equals 0, because differentiating a constant such as 1 always gives you 0. Applying the product rule here and simplifying, we end up with d sec of x equals tan of x sec of x dx. The procedure for differentiating cosec of x is very similar and leaves you with negative cotan of x cosec of x dx. We have just finished differentiating the 6 trigonometric functions. For future use, it is useful to list all of them in a table. So here is an example of such a table. Anyways, that's the end of the video. If you enjoyed it, please like. And if you want to be notified next time I upload a calculus video, please subscribe so you don't miss it. Bye!